All right, this is just a quick video on the 424 lab sheet that we have for this lesson that we normally would be having here in class, okay? So what we're going to do is we're going to develop and continue to work with our ideas about ratios. So during this, Katura was making a berry drink from a bag of powdery mix. The directions said to use 5 scoops of powder for every 8 cups of water. Her pitcher holds 12 cups of water. For each of these problems, I would encourage you to pause, try the problem, then check the answer, okay? Because I'm just going to kind of fly through with the answer, but your learning will be better if you pause, try it yourself, and then come back and watch that video, okay? All right, so what I'm going to do is I'm going to say that we have 5 scoops of the powder. We'll just use red to indicate that. And then we'll use 8 cups of water. We'll use blue for that, okay? So what's the ratio of powder? Right, powder to water. So to be powder to water, it must be 5 scoops to 8 cups. Oops, sorry. 8 cups. Okay. All right. Now work with your team to find out how much powder Katura needs to mix with 12 cups of water. 12 cups of water, right? Okay. So to do 12 cups of water, right there, describe or show how you know or whatever. So what we can say is we already know that, Katura needs 5 scoops for 8 cups. Okay, now what we could do is we could cut this in half, just cut this recipe in half, right? Which would make this now 4 cups, and then I could cut the 5 in half to get 2.5, right? Now, how is that helpful for me? Well, if we take a look and we were to actually add now what we have here, notice that if I put a full recipe in there with a half a recipe, that would give me the 12 cups of water that I'm looking for. Well, how many scoops do I need for a regular recipe? 5. How many do I need for half a recipe? The 2.5. So 5 plus the 2.5 leads to 7.5 scoops or 7.5 scoops of powder. Now, another way to do this that I've been showing other classes and stuff like this is to say, okay, what if we wanted one recipe? So we need 5, right? 5 scoops, 8 cups. What if we doubled the recipe, right? Let's say we double that recipe, so then I need 10 scoops, and then I would get 16 cups of water. Let's triple the recipe. Let's do one more batch. To do one more batch, I'd need 5 more scoops, or 15 in total, and I would need 24 cups of water, right? Now, how is that helpful for me, right? Well, if we recognize here that this is exactly double, right? 24 cups is exactly double the 12 cups I need. Well, then why don't we cut that 15 in half to get 7.5, right? And ultimately what we're doing is we are building a double number line with all of this. 1, 2, 3, 4, 5, 6. That should be good enough. And if I need 5 scoops, 10, 15, 20, I don't know what we all need in here, 25 scoops, and then how many cups of water? 8, 16, 24, 32, and what do we need here? 40 for that one, okay? So now to get to the 12 cups that we are asking about, or we're talking about, right? The 12 cups is where? Well, that is not exactly, sorry about that. 8, yeah, the 12 cups, sorry, is directly in between here, right? And then that's where we could also find that 7.5, right? Using the double number line to get there, okay? What's the ratio? Well, actually, we kind of wrote the ratio a little bit already, right? That ratio is powder to water. That's 7.5 cups of powder to 12 cups of water, all right? Mrs. Hartley's students are working with their mix of raisins and peanuts. Each student took out a sample of the mix and counted the raisins. The class found that 30% of the mix was raisins. Sophie knows that 30% is the same as 30 over 100. This can be thought of as a ratio that compares the amount of raisins 30 to the total number of items in the mix 100. Write an equivalent ratio with the denominator of 100 to represent that same comparison. Okay, if we have that 30 over 100, and we're trying to make it to a denominator over 10, right? What would that be? Most of you probably can figure that out really quick. If we just divide both of these by 10, 100 divided by 10 is 10, and 30 divided by 10 is 3. So we would have 3/10. Again, make sure you pause between each of these and try them as we move along. Sophie wants to write a ratio comparing the number of raisins to peanuts, not the total. Write this ratio and explain how you determined it without having to count the peanuts. So the raisins, remember, is 30%, or we could look at it as the 3, right? That's the 3 part. Well, then what's the rest of the mix? The rest of the mix is the peanuts. So that would be the 7. So we would write that ratio as a 3:7. Okay. Now, Sophie knows that for every 30 raisins, there will be 70 peanuts in the mix. However, and so that what that means basically is this ratio could have been 30 to 70 also, 30% to 70%. However, when she took out her original sample, she counted 42 peanuts in it. Write an equivalent ratio that will help Sophie figure out how many raisins she should have in her sample that contained 42 peanuts. So this is where I think that double number line is a really good idea, right? And if we said this was the raisins and this is the peanuts part, right? All right. So what we need is, let's go to the peanuts, and we know that the peanuts have to be 42. So our ratio is a 3:7. So let's do the peanuts part until we get to 42. So 7, 14, 21, 28, 35, 42. So that's what I'm looking for, right? So let's increase the raisins then by that 3. 3, 6, 9, 12, 15, 18. The ratio is an 18 to 42. Another way maybe that you could look at it is 7 times 6 is 42, and so 3 times 6 is 18, right? And that's actually what happens here, right? Times 6, and then times 6. Okay. All right. Nikki is setting up a carnival machine with 3 teddy bears, 7 stuffed frogs, 3 rubber duckies, and 2 stuffed dinosaurs. Write the following ratio for Nikki's machine. Take some time to write down these and then come back and check it out. The number of teddy bears to total prizes. There's 3 teddy bears to total prizes. 3 plus 7 plus 3 plus 2 is 15. The number of teddy bears to the number of stuffed dinosaurs. There are 3 teddy bears to 2 dinosaurs. The number of teddy bears to the total number of other prizes. Other prizes. So anything not teddy bears. We have 3 teddy bears, 2. So we would add the 7, the 3, and the 2 for this one. The 7 and 3 puts me at 10 plus 2 leads me to a 12. Okay. What percent of the prizes are teddy bears? Okay, pause and give that a try. Percent. All right, so what I'm looking at in this one is I see that I'm going to rewrite the ratio of teddy bears to total prizes as 3 to 15, which I could also look at as 1 to 5, right? That's a 1 to 5 ratio. Divide them both by 3. How could I get to the percent? Remember, a percent is when we multiply by a fraction or multiply to get a fraction that's over 100. So I'm going to multiply by a giant 1 here. And 5 times 20 is 100. There's my giant 1. So then that means that 1 times 20 is 20 to give me 20%, right? Cent is 100, 20%. Okay. Alrighty, and then lastly, Nikki's setting up a machine that holds 60 total prizes. How many teddy bears will be needed in the machine? We can use this same fraction. Again, pause. Try it out. We can use this same fraction, 3/15. to get how many teddy bears will be in this machine for 60 total prizes. Well, this is the exact same thing that we just did, right? We want to have our ratio of 3 to 15 to get us to 60 total prizes, right? There's my giant one again. Whoops. There we go. And 3 times 4 is 12. Right? And so we have 12 teddy bears. Another way to do this is setting up our teddy bears to total. Setting up a double number line again. Right? And what we could do is we could say that it's 3 teddy bears to 15 total, and we need to get all the way up to 60 total prizes. So we'd say 15, 30, 45, and 60, right? So 3, 6, 9, 12. There we go. All right, if you have any other questions, please let me know. Have yourself a great day.